Did you know that a single giant excavator can cost more than $20 million and weigh as much as 800 tons? That's equivalent to about 100 African elephants. But here's what's even more mind-blowing. These mechanical monsters aren't just rolled off an assembly line. They're meticulously hand-built over several months by teams of specialized engineers. And the final assembly? It happens in a sequence so precise that a single mistake could cost hundreds of thousands of dollars to fix. Today, we're going behind the scenes to witness how these colossal machines are assembled from scratch. From the first steel cut to the moment its massive tracks touch the ground for the first time. And stick around until the end, because we'll reveal the most critical 60 seconds of the entire assembly process. The moment that determines whether this multi-million-dollar machine will work perfectly or become a catastrophic failure. Let's dig in. Before we dive into the assembly process, you need to understand just how massive these machines really are. We're not talking about the excavators you see on your local construction site. We're talking about mining excavators, the titans of the heavy machinery world. The Liebherr 9800, one of the largest hydraulic excavators in the world, stands nearly 10 meters tall. Its bucket can hold 47 cubic meters of material. That's enough to fill a standard swimming pool in just 20 scoops. The boom alone weighs 70 tons, and when fully extended, it can reach distances of over 20 meters. But size is just the beginning. These machines contain over 30,000 individual parts. They have hydraulic systems that operate at pressures exceeding 350 bar. That's about 100 times the pressure in your car tires. The main hydraulic pumps can move 2,000 liters of oil per minute. To put that in perspective, that's like filling 40 bathtubs every 60 seconds. And here's something that'll blow your mind. The engine alone can produce over 4,000 horsepower. That's more power than 4 Formula One race cars combined, all housed in a single machine designed to dig, lift, and move earth all day, every day. So how do you even begin to assemble something this complex? The assembly of a giant excavator doesn't start in a factory. It starts months earlier, with engineering blueprints and computer simulations that map out every single component, every bolt, every hydraulic line. But when physical assembly begins, it all starts with one crucial element: the undercarriage. The undercarriage is essentially the excavator's foundation, its feet, if you will. This is where the massive tracks are mounted, and it's designed to support hundreds of tons of weight while distributing that load evenly across soft or uneven terrain. Assembly begins with the track frames. These are enormous steel structures, each one precision welded in specialized jigs to ensure perfect alignment. Any deviation of even a few millimeters here will cause problems later. Uneven wear on tracks, stability issues, or worse. Each frame is built from steel plates that are several inches thick and require welding by certified specialists. A single track frame can take a full week to complete. Next come the track rollers. These aren't your average wheels. Each roller is a sophisticated sealed bearing unit designed to support immense loads while rolling smoothly over rough terrain. A single excavator might have 20 or more of these rollers, and each one must be positioned and tensioned with extreme precision. Then the tracks themselves are assembled. These aren't rubber belts like on a tank. We're talking about individual steel track shoes, each weighing several hundred pounds, connected by massive pins and bushings. The track shoes are grouser style, meaning they have raised ridges designed to dig into soft ground for traction. Installing these tracks requires specialized hydraulic presses and can take several days. But here's the fascinating part. The tracks are deliberately assembled with a specific amount of tension. Too loose and they'll slip or derail. Too tight and they'll wear out prematurely or put excessive stress on the rollers. Finding that perfect tension is an art form that comes from years of experience. With the undercarriage complete, the next phase is constructing the excavator's rotating platform, the house. This is the section that actually rotates 360 degrees and contains the operator's cab, engine, hydraulic systems, and counterweights. The house begins with the car body, a massive steel frame that serves as the skeleton. This structure must be incredibly strong because it supports the weight of the entire upper portion of the machine while also withstanding the enormous torque forces generated when the boom swings a fully loaded bucket. The car body is assembled from dozens of steel components, each precisely cut, shaped, and welded together. This isn't welding you can do in your garage. We're talking about certified welders using specialized techniques like submerged arc welding, which can join thick steel plates with welds that are actually stronger than the base metal itself. The welding process alone can take several weeks. Once the car body frame is complete, the swing bearing is installed. This is one of the most critical components of the entire machine. It's essentially a giant ball bearing race, often measuring more than 3 meters in diameter, that allows the entire upper structure to rotate smoothly. The swing bearing contains hundreds of massive steel balls, or rollers, each precision machined to tolerances measured in hundredths of a millimeter. Installing the swing bearing is a delicate operation. Despite weighing several tons, it must be positioned with absolute precision. Even a slight misalignment can cause uneven wear, increased friction, or catastrophic failure down the line. Specialized fixtures and laser alignment tools ensure perfect placement. Next, the swing drive motors are mounted. These hydraulic motors provide the torque necessary to rotate hundreds of tons of machine and material. They're connected to the swing bearing through a massive gear reduction system that converts the motor's high-speed rotation into the slow, powerful movement needed to swing the excavator's boom. Now comes one of the most complex phases, installing the power systems and hydraulic circuits. The engine is the heart of the excavator. These aren't automotive engines, they're industrial power plants built for continuous operation under extreme loads. A typical mining excavator uses a turbocharged diesel engine with 12 or 16 cylinders, producing thousands of horsepower while meeting strict emission standards. The engine is lowered into the car body using an overhead crane. It sits on specially designed mounts that isolate vibration while maintaining precise alignment with the hydraulic pump drive systems. Once positioned, technicians connect the cooling systems, fuel lines, air intake, and exhaust, each connection checked and rechecked for leaks. But the engine is just the beginning of the power story. The hydraulic system is what actually makes the excavator move. Multiple high-pressure hydraulic pumps, each the size of a beer keg, are mounted directly to the engine. These pumps convert the engine's mechanical energy into hydraulic power, pushing high-pressure oil through a network of valves, hoses, and cylinders. The hydraulic system is astonishingly complex. Miles of hydraulic hoses and steel lines are routed throughout the machine, each one carefully positioned to avoid chafing, heat damage, or interference with moving parts. Every connection must be torqued to exact specifications and tested for leaks. A single failed hydraulic line under full pressure can spray oil with enough force to cut through skin. The control valves are installed next. These are the components that direct hydraulic fluid to the various cylinders and motors based on operator inputs. Modern excavators use sophisticated electro-hydraulic controls, where the operator's joystick movements are converted into electronic signals, which then precisely control servo valves. This provides incredibly smooth, responsive control, despite the massive forces involved. Then comes the electrical system. While excavators are primarily hydraulic machines, they contain extensive electrical networks for engine management, sensors, diagnostics, lighting, climate control, and increasingly sophisticated computerized control systems. Hundreds of sensors monitor everything from hydraulic pressures to engine temperature to boom position, feeding data to onboard computers that optimize performance and detect potential problems before they become failures. Now we reach the most visible part of the excavator, the boom and arm assembly. This is what most people picture when they think of an excavator. That long, articulated arm with a bucket at the end. The boom is a massive steel structure, often built as a box beam or lattice framework for maximum strength with minimum weight. The largest excavators have booms that are 12 meters long or more and weigh 70 tons or more. These aren't shipped as single pieces. They're transported in sections and assembled on-site or in the factory using huge fixtures that hold everything in perfect alignment while welders join the sections together. The boom is attached to the car body through enormous pivot pins, solid steel shafts several inches in diameter that can withstand millions of pounds of force. These pins are precision machined and fitted with bronze or composite bushings that allow smooth rotation while supporting extreme loads. The stick, or arm, connects to the end of the boom through another massive pin joint. It's similar in construction to the boom, but typically shorter. The bucket attaches to the end of the stick through, you guessed it, another pin connection. Here's where it gets really interesting. Each of these joints is moved by massive hydraulic cylinders. The boom cylinder, the largest of all, might be 8 meters long when fully extended and capable of exerting over 1,000 tons of force. These cylinders are precision-manufactured components with chrome-plated rods, high-performance seals, and internal cushioning systems that prevent shock loads. Attaching these cylinders is a careful process. Each one weighs several tons and must be positioned precisely, with pins driven through the mounting points using hydraulic presses. Once installed, hydraulic lines are connected and the system is carefully filled with oil, bled of air, and tested. The bucket itself is a marvel of engineering. Built from high-strength, wear-resistant steel, often with replaceable teeth made from hardened alloy, a single bucket can weigh 15 tons or more. The bucket attaches using a quick coupler system that allows operators to change between different buckets or attachments, rock buckets, digging buckets, ripper tools, without leaving the cab. While all this heavy metal work is happening, the operator's cab is being assembled separately. Modern excavator cabs are sophisticated environments designed for comfort, safety, and optimal control during 12-hour shifts. The cab structure is built with ROP's and FOP's certification. That's Rollover Protection System and Falling Object Protection System. The steel structure is designed to protect the operator even if the entire machine rolls over or if large rocks fall onto the cab. Inside, the cab is outfitted with an air suspension seat, climate control, multiple display screens showing camera feeds and machine diagnostics, and the control interface, typically 2 joysticks that control all boom, stick, bucket, and swing functions. Modern cabs also include advanced features like GPS guidance systems, payload monitoring, and even semi-autonomous functions. The completed cab is lifted into position on the car body and secured with vibration-isolating mounts. All electrical connections, hydraulic lines for climate control, and control system cables are connected and tested.
Now, after months of work, thousands of parts, and countless hours of skilled labor, we arrive at the moment we promised at the beginning, the single most critical phase of the entire assembly process. It's called first hydraulic startup. This is the moment when, for the first time, the engine starts. The hydraulic pumps begin turning, and high-pressure oil flows through the entire system. It's the moment of truth that reveals whether everything has been assembled correctly. Experienced technicians monitor dozens of parameters: oil pressure, engine temperature, hydraulic flow rates, electrical system voltage. They listen carefully to the sound of the pumps, feeling for vibrations that might indicate problems. They watch for oil leaks at hundreds of connection points. Then, slowly, methodically, they test each function. The boom lifts for the first time. The stick extends. The bucket curls. The entire upper structure rotates. Each movement is tested through its full range of motion, checking for binding, leaks, unusual sounds, or erratic behavior. This process can take days. Any problem discovered means tracing hydraulic circuits, checking electrical connections, verifying sensor readings. Sometimes major components must be removed and reinstalled. But when everything checks out, when the machine operates smoothly through all functions, when all pressures and temperatures are within specifications, when the computerized systems show green across the board, that's when this collection of 30,000 parts truly becomes a functioning excavator. Final testing includes load tests, where the bucket is filled with material to verify lifting capacity. Speed tests check how quickly the boom can cycle through a complete dig and dump sequence. Fuel consumption is measured, hydraulic system efficiency is verified, and every safety system is validated.
And there you have it, the incredible journey of how a giant excavator is assembled from scratch. From the first steel cuts of the undercarriage to that critical first startup, it's a process that combines old-school craftsmanship with cutting-edge technology. These machines represent the pinnacle of heavy equipment engineering, assembled by skilled technicians who understand that every bolt, every weld, every hydraulic connection matters. Because when a $20 million machine heads to a remote mining site, it needs to work flawlessly, day after day, moving mountains of earth and keeping entire operations running. If you found this fascinating, hit that like button and subscribe for more behind-the-scenes looks at the world's most incredible machines. And drop a comment below. What other massive machines would you like to see assembled from scratch? Until next time, keep digging deeper.